This is our fundamental theorem of algebra 2.5 part 2. We're going to talk about conjugate pairs. We're going to talk about how to find real roots. Today we're going to be kind of working backwards from everything that you guys have been doing. This thing about conjugate pairs is really, really, really important. Okay? Whenever they give you a zero, they'll say, write the polynomial given these zeros. They're going to give you real ones and they're going to give you imaginary ones. How do you know that a zero or something that they give you is imaginary? What will it have in it? How do you know a number is imaginary?
It have a plus in the equation.
Not a plus. What's the letter that tells you that it's imaginary? An I. It'll have an I in it, okay? So when they give you a zero that has an I, you have to account for the complex conjugate. Because remember, we don't like to have i's just hanging out. You guys don't ever get a polynomial that says, 2x squared plus 3xi. That doesn't happen. Whenever you are given a zero, so say if they give you one of the zeros of the polynomial is 2i, you also have to know, they're not going to tell you this, you have to write down, oh, if I have positive 2i, then I'm also going to have negative 2i. Because what happens, guys, when you multiply positive 2i and negative 2i? What happens here? What's 2 times 2? Negative 4. I squared. As soon as you see I squared, negative 4i squared. What happens with negative 4 with I squared? You cross this off, this becomes a positive, all right? So whenever you are given, and I'll show you this in a second, whenever you are given an imaginary or a complex number, you have to account for its conjugate. And you'll see what I mean in 1 second. You guys are going to be writing polynomials, all right? You're working backwards. Instead of giving the big polynomial and finding all the zeros, you're going to be given the zeros, and you need to find the original polynomial. So this right here, this question says, find the 4th degree polynomial. If it's the 4th degree, when you write your polynomial answer out, what should your highest exponent be? 4. So this says the real coefficients, or your zeros, are x equals negative 1, x equals negative 1, and x equals 3i. What do you know about 3i? Is it imaginary or real?
Imaginary.
It's imaginary. So right away you have to go, oh, wait a second. If they gave me 1 imaginary, I have to account for the conjugate. So what is the opposite or the conjugate of positive 3i? Negative 3i. Do you guys see that? Every time. That only happens with the imaginaries. You don't do that with the reals. If they tell you it's 1, it's 1. That's it. So now all you're doing from this point, guys, is working backwards. We're going to go backwards to create the polynomial that we would start with. So I'm going to write all of my answers as binomials multiplied together. So when I move negative 1 to this side, it becomes what? So x plus 1. When I move this one over, it becomes x plus 1. When I move positive 3i over, it becomes x minus 3i. And when I move this over, it becomes x plus 3i. And this is all set equal to 0. And all we do now is FOIL. Can you FOIL 4 things together at one time? No. So do the first 2. What's x times x? X squared. X times 1. X. 1 times x. And 1 times 1. So if I combine like terms, I have x squared plus 2x plus 1. Everybody agree? All right. This is just very basic, but really easy to make mistakes, so make sure you're paying attention. Now I'm going to do the second 2. So x times x is x squared. X times positive 3i. 3ix or 3xi. Okay. Then what's negative 3i times x? Minus 3ix or xi. And then negative 3i and positive 3i. Minus 9i squared. What happens when you see I squared? You cross it off and you change the sign. So I have left x squared. What happens with positive 3xi and a negative 3xi? They cancel out. And you have plus 9 equals 0. Do you guys see how we're working backwards? If you were to solve x squared plus 9, you go, oh, that's an imaginary. So now we just FOIL one more time. X squared times x squared is x to the. X squared times 9 is 9x squared. Good. 2x times x squared is plus 2x cubed. 2x times 9 is 18x. 1 times x squared is x squared. And 1 times 9 is 9 equals 0. And then what's the last thing we do? Put it in standard form. Combine like terms. So I have one thing that has x to the fourth, correct? All right, what's the next exponent I have?
2x.
Okay, plus 2x cubed. Now what? Plus 10x squared. Now what? Plus 18x. Then what? Plus 9. Now to finish off your answer, you either have to have equals 0, or you could write f of x equals x to the fourth plus 2x cubed plus 10x squared plus 18x plus 9. The only thing that is difficult about this, other than keeping yourself organized and making sure you multiply correctly, is remembering that when they give you an imaginary or a complex number, you have to account for its conjugate. Let's look at these examples. I'm not going to do all of them. I guess we can. We can go through it quickly. What do you notice about number 1? They're all real, right? So this is just basic algebra. What do you notice about number 2? They're both real, but one of them's a what? A square root. You still treat it the same way. Number 3, you have an imaginary, and in number 4, you have an imaginary. So let's go ahead and let's do number 1 together. Now, guys, you don't have to do this, but I think it's best for your vision to write them out like this so you get your parentheses correct. Now, the x equals 0, right? You can move this over and make this x plus or minus 0, right? But then you'd have to distribute that 0 throughout. So if I were you, if you have an x equals 0, just at the end, stick the x. You understand what I mean? Okay, I'll show you in 1 second then. Let's write our parentheses. What does this parenthesis look like?
X plus 5.
X plus 5, right? Because you move this over. What does x equals 2 look like? X minus 2. And do you agree that when if I move 0 over, it looks like that? Yes? Equals 0? Well, you don't have to go through and distribute 0 because it's just going to be 0. So I would FOIL these two together. So let's FOIL these first. X times x is x squared. X times negative 2. Negative 2x. 5 times x.
5x.
Plus 5x. And then 5 times negative 2.
Negative 10.
Negative 10 equals 0. Combine like terms. X squared plus 3x minus 10 equals 0. Agreed?
Yeah.
Well, if you have this x minus 0 on the outside, what are you doing with the x? Distribute it. What's x cubed plus 3x squared, right? Minus 10x. What happens when you distribute 0? Everything's just 0. So you can write the x minus, that's fine. It can be x minus or x plus. But all you're really doing at the end is just multiplying everything by an x term. So equals 0. Or you can have f of x, g of x, h of x, whatever at the front. But you're going from your answers to the original. So if you wanted to check whatever your answer is, you should be able to go through our factoring process. Whether it's GCF, difference of perfect squares, 4 terms you group, doesn't work as P over Q, whatever. You should be able to work backwards with that. Let's look at this one. How many zeros do you have here? Nope, just 2. They're both real, guys. You have x equals negative 5, and you have x equals what? The square root of 3. That's it. It's not plus or minus. They're just telling you it's the square root of 3. So when I move this over, it becomes x plus 5. When I move this over, it becomes x minus the square root of 3. And we set it equal to 0. FOIL. Remember, when you have a whole number times the square root, you cannot multiply it. The value doesn't change. You just stick them together. So x times x is x squared minus what? Minus x square root of 3. Then I have 5 times x is plus 5x. Then I have minus 5 root 3. Can I combine anything here?
No.
No. I do have 2 radical root 3's, but one of them has an x in front, one of them has a 5. There, right there, is your polynomial. That's it. Cannot combine anything else. Now we'll move to the ones that we have to think a little bit here. All right, I'm given 2 zeros here, but one of them is what? One of them is imaginary. That means I have really how many? 3. I have x equals positive 2i and x equals negative 2i. Whenever you have an imaginary, you have to account for the conjugate. So as we work backwards here, this becomes x plus 1. This becomes x minus 2i. And this becomes x what? Plus 2i. And it's all set equal to 0. I would FOIL the second 2 first. Just leave x plus 1 out here, hanging out. So x times x is x squared. X times positive 2xi. Sorry. Yeah, I just said it. Negative 2i times x is negative 2xi. Negative 2i and a positive 2i is negative 4i squared. Good. What happens when you see I squared?
Cross it off.
Cross it off. Change the sign. What happens to my 2xi's? They cancel out. Guys, you never have a polynomial that has x and i's in it. So when you do this, every single time that term should cancel out. Every single time. And now we multiply one more time. What's x times x squared? X cubed. What's x times 4? Good. 1 times x squared. And 1 times 4. Now write it in standard form. X cubed plus x squared plus 4x plus 4 equals 0. Or f of x, g of x out in front. Change this one to x equals 2 plus 3i and negative 4. There's just a lot going on in that problem right there. Let's change it to this. What do you see here? Tell me what you see. I see an imaginary. As soon as I see an imaginary, I need to remember, okay, I have 2 plus 3i. I also have the conjugate, which is 2 minus 3i. Very good. And I have x equals negative 4. All right, we don't have to worry about that one right now. Now, when you pull this over, right, this whole thing is right here. It's together, correct? Both of them are positive or negative?
Positive.
They're both positive. Do you see how the leading term is positive? Yeah. All right. So when I bring it over in my parenthesis, this becomes x minus 2 plus 3i times x minus 2 minus 3i. You guys see that? Okay. And then what goes at the end? X plus 4. Can I put it at the front? Yeah. Now, there's 2 ways you can look at this. I'm going to show you a shortcut, which I think is the way that you should do it. But I'm going to do it the long way here for a second, just to show you. This will work. If you guys don't want to write this part down, you don't have to. I'm going to do it in the video so you can see it. But if I FOIL these 2 parentheses out, it's going to be a huge problem, but you can do it. What's x times x? X squared. Just follow along with me on this one. What's x times negative 2? Negative 2x. And then what's x times negative 3i? Negative 3xi, or ix, doesn't matter. Okay, I'm going to switch colors now. I'm going to do negative 2 to x gives me what? Negative 2x. Negative 2 to negative 2 is positive 4. And negative 2 to negative 3i is, what is it? Positive 6i. Everybody with me? Okay, one more color. 3i to x is 3xi or 3ix. 3i to negative 2, negative 6i. And then 3i to negative 3i, negative 9i squared. As soon as I see I squared, I cross it off and change the sign. Does everybody agree with me? Did you see what I just did there? It's a big problem. So let's combine like terms. I have x squared. Anything else have an x squared? No. So I have a negative 2x and a negative 2x gives me what? Negative 4x, okay. I have a negative 3xi and a positive 3xi. It cancels out. I have a positive 6i and a negative 6i. What happens? Cancels out. So then I have 4 plus 9. 13, okay? You guys with me? And then don't forget about our random x plus 4 up there. So x plus 4 equals 0. And now we're going to multiply again. What's x squared times x is x cubed. X squared times 4 is 4x squared. Negative 4x and x is negative 4x squared. Negative 4x and 4, negative 16x. 13 times x, 13x. And what's 13 times 4? 52. And now we say, okay, x cubed. Okay, so minus 16x. No, we got to combine. What's negative 16 and 13? 3x plus 52 equals 0. Let's go back to this step right here when we wrote our parentheses. When we had x minus 2 plus 3i and x minus 2 minus 3i, right? And then we had our x plus 4. Let's go back there. Now, if you don't see this, it's okay, but this will happen every single time. What do you notice, guys? Right here. It's the same. I can write this as x minus 2 quantity squared. What do you notice about this and this?
They're opposite.
It's the same term though, right?
Yeah.
So can I write this as 3i quantity squared? And look at the signs in the middle. Are they the same or are they different? They're different. So if I have x minus 2 quantity squared, x minus 2 times x minus 2. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 and negative 2 is positive 4, right? Correct? Minus. What is 3 squared? 9. And what is I squared? I just read I squared, right? What happens when I see I squared? Cross it off and change the sign. So if I combine like terms here, I have x squared minus 4x plus what? 13. Is that what I got right here?
Yeah.
Is that a little bit of a shorter process? Do you guys see that? That will work every single time. I'll do another one so you guys can see it, but that will work every time. And then we can just go through and multiply. X squared times x is x cubed. X squared times 4x is plus 4x squared. Negative 4x and x is negative 4x squared. Negative 4x and 4 is negative 16x. 13 times x is plus 13x. And 13 times 4 is plus 52. If we combine like terms, we have x cubed. What happens to my 4x's? They cancel out. Negative 16x and a positive 13 is negative 3x. Plus what? Equals. Is that what we got up here? Same thing? Much shorter process. On your test, you guys will have one or two of those. Here's the roots, find the polynomials. You only have one that's super long. You will have one or two of these that says find all the zeros. Given. All right? Every single time they're going to give you a complex zero. This process will not change. They're going to give you a complex zero. You have to find the real ones. How many zeros should I have for this problem? 4. How many did they already give me? Nope.
2.
They already gave me 2. What are the 2 that they already gave me? 1 plus 3i and 1 minus 3i. Good. They gave me 2. I'm going to find the other 2. So here's the process. The first thing you do is you multiply those 2 together because we need those i's to cancel out. So if I move this over here, it becomes x minus 1 plus 3i. If I move this one over here, it becomes x minus 1 minus 3i. Agreed? Do you guys agree?
Yes.
Okay, so now look, we can do the trick. What do you notice right here? Do you see how you have x minus 1 here and an x minus 1 here? All right, we can write that as x minus 1 what? Quantity squared. What is your second term? 3i. So I can write that as 3i what? Quantity squared. Good. And then what sign goes in the middle? A minus. Very good, guys. So when you multiply this out, if you can't multiply it in your head, no worries, just write it. What's x times x? X squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1, right? Yes? You guys with me? Okay. So then I have minus. What do I do with this too? It goes to both. Goes to the number and to the I. So when you square 3, what does it become? 9. And then I have I squared. When you guys see I squared, what do? Cross it off and change the sign. So let's combine like terms. I have what? X squared minus 2x plus 10. All right, that's part of the problem. Now what you're going to do, because we're trying to find the remaining zeros, you're going to use long division. You're going to take your original polynomial, x to the fourth minus 3x cubed, blah, 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 and you're going to divide it by x squared minus 2x plus 10. You're going to take the imaginaries, combine them, multiply them together, to then divide your original polynomial by that to find the real ones. So I have, read it to me so don't write it wrong. X to the fourth minus 3x cubed, right? Plus 6x squared plus 2x minus 60. And we're going to divide it by, what did we just find? X squared minus 2x plus 10. Every single time, guys, this will work. If you did it right. You're not going to get anywhere it's no solution or your division's really weird. It will work every time. First term into first term. X squared times what gives me x to the fourth? X squared. So look, I'm going to put it right here above my x squared. And then I get my subtraction ready. There's 3 terms, so your subtraction should be 3 terms wide. Now multiply. What's x squared times x squared? X to the fourth. What's x squared times negative 2x? Negative 2x cubed. What's x squared times 10? Plus 10x squared. Before you subtract, what do you have to do? Change, 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 change. What's 6x squared minus 10x squared? Negative 4x squared. What happens with negative 3x cubed plus 2x cubed? Negative x cubed. And what happens to my x to the fourths? And then what do I do with the 2x? And then we do the exact same thing. Long division again. First term into first term. X squared times what gives me negative x cubed? Negative x. Get your subtraction ready. And multiply. What's negative x times x squared? Negative x cubed. What's negative x times negative 2x? Plus 2x squared. What's negative x times 10? Minus 10x. Before I subtract, what do? Distribute, 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 distribute. Okay, so what's 2x plus 10x? 12x. What's a negative 4x squared and a negative 2x squared? Negative 6x squared. Cubes cancel out. What do I do with this negative 60? I bring it down. Again, first term into first term. X squared times what gives me negative 6x squared? Good. Negative 6. So get your subtraction ready. Negative 6 times x is negative 6x squared. Negative 6 times negative 2, 12x. And then negative 6 times 10 is negative 60. Before we subtract, what do we do? Distribute, 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 distribute. What do you guys notice? It all cancels. So this is what you're left with. Is that my answer? No, we're real close. I'm left with x squared minus x minus 6 equals 0. Can I factor that?
Yes.
What are the factors of negative 6 that multiply to give me negative 6 but add to give me 1? X minus 3, x plus 2. So the remaining roots are x equals 3 and x equals negative 2. How many answers should you have?
4.
How many do we have?
4.
Good. All right. The beauty of this, and I promise you, I did all the tests and I photo mathed it just to make triple 100% sure everything works out nice and pretty. I took a lot of time to make these tests to make sure that it was all correct. The process is the same. They're going to give you one of these imaginary numbers, a complex root. You're going to multiply that together, then use long division, and you'll be able to factor with whatever's left over. If at some point you get a remainder or something like that, you need to just erase and start over because you did something wrong. So the first thing we do is we say, okay, they gave me x equals 3 plus 2i. What else do I need to write down? X equals 3 minus 2i. The complex conjugate, you have to account for that. So the first thing we're going to do real quick, guys, is we're just going to multiply those two together. So I have x minus 3 plus 2i and x minus 3 minus 2i. Agreed? Everybody with me? Okay, let's do our little shortcut. What's the beginning that is the same? So I have x minus 3 quantity squared. The second term that is the same as what? 2i, and I have quantity squared. And then what sign goes in the middle? Your minus. Good. So x minus 3 quantity squared is just x minus 3 times x minus 3. So x times x, x squared. Negative 3x and a negative 3x is what? Negative 6x. And then negative 3 times negative 3 is positive 9. Minus, what do I do with this 2? I have to distribute it to both the number and the letter. Make sure you guys do that. So 2 squared is 4, and then I have I squared. As soon as I see I squared, what do? Cross it off and change what? The sign. So I have x squared minus 6x plus what? 13. And I'm going to divide that into x cubed minus 11x squared plus 43x, right? And then what? What was the last one? Minus 65. Everybody with me? Yes? Talk to me. I know this is a lot. Okay, so first term into what? First term into first term. X squared times what gives me x cubed? X. Where am I going to put my x? I'm going to put it over here, above the x. This is an easy one. Get your subtraction ready. So now multiply. What is x times x squared? X cubed. What is x times negative 6x? Negative 6x squared. And what's x times 13? Plus 13x. Before I do my subtraction, I need to do what? Change, 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 change. So what's 43 minus 13? Okay, so I have 30x here. What's a negative 11? X squared and a positive 6x squared. Negative 5x squared. And then what do I do with this minus 65? You bring it down. How many answers should I have for this problem? 3. How many do I already have? 2. Okay, so I just need to find one more. So x squared into negative 5x squared. X squared times what gives me negative 5x squared? Negative 5. Now what should happen when I multiply and then subtract here? everything should cancel out. So negative 5 times x squared is negative 5x squared. Negative 5 times negative 6 is positive 30x. Negative 5 times 13 is negative 65. Before I can subtract, what do? Distribute, 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 distribute. What's a negative 65 and a positive 65? 0. What's 30 and negative 30? 0. Negative 5 and positive 5? 0. So I'm left with x minus 5 equals 0. What is the remaining x value? X equals 5. It's not that awful. It really isn't. It just takes a minute to do. But at the beginning, you should know, okay, I have this many zeros that they gave me. I have to find this many more, right? Okay, how's this 0 that they gave us a tad bit different? The first number is negative. So when you move it over, what's it going to become? Positive. You just have to pay attention to that, okay? So I have x equals negative 2 minus 5i. What's the complex conjugate? Negative 2 what? Plus 5i. Okay, good. So when we move this over, instead of x minus, it's going to become x what? Plus. Okay, same thing here. So when I multiply these two together, I have x plus 2 minus 5i, and I have x what? Plus 2 plus 5i. Multiply the two together. The process does not change. What is the first term that's exactly the same? X plus 2, and I have it quantity squared. What's the second term that is the same? 5i, and I have that quantity squared. And what is the sign that goes in the middle? Minus. Perfect. So if I have x plus 2 quantity squared, that's x plus 2 times x plus 2. So when we work that out, ladies and gents, you have x squared. 2x and 2x gives me 4x. Good. Plus 2 times 2 is 4. Minus. Now here's a really important part that if you miss this, you're going to have boo-boos in the middle here. This 2 goes to the 5 and to the I squared. What is 5 squared? 25, and then I have I squared. As soon as I see I squared, what do? Cross it off, change the sign. So what have I created? X squared plus 4x plus 29. Everybody with me? Don't get intimidated by the numbers, guys. They'll all work out pretty. So I have x cubed plus 11x squared plus 57x, and then is it 203?
Yeah.
Okay. Now, how many answers am I looking for? 3. How many do I already have? 2. So this is going to be another one of those easy ones. I'm going to say first term into first term. So x squared times what gives me x cubed? X. Put it right here above the 57. Get your subtraction ready. Multiply. X times x squared is x cubed. X times 4x is plus 4x squared. X times 29 is plus 29 what? X. Before you can subtract, what do you need to do? Distribute, 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 distribute. What is 57 minus 29? So I have 28x. What's 11x squared minus 4x squared? 7x squared. And then I bring down my 203, right? So first term into first term. X squared times what gives me 7x squared? 7. Positive 7? Yep. So get your subtraction ready. What is 7 times x squared? 7x squared. What's 7 times 4? Plus 28x. What's 7 times 29?
200.
It is 203. Good. Before you can subtract, what do? Distribute, 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 distribute. What's a negative 203 and a positive 203? What's 28 and negative 28? What's 7 to negative 7? So you're left with x plus 7. Whatever you're left with, you factor. If it's just simple like this, then my x value is what? X equals negative 7. If you're left with a trinomial that you have to factor, factor it. You guys can do that. But the process is the same every single time. You take the complex number that they gave you and write down the conjugate. Multiply those two together. Divide your polynomial by that that you just created, and then factor your answer. Lots of algebra. You guys got to take your time, but I have more practice problems for you. You have practice tonight on your WebAssign that you guys can work on. And then I'll give you a test review that has more to